Usually when you arrive at your front door with an armful of groceries, it's just a really physical, friction-filled experience.
Oh, yeah.
You're shifting heavy bags to one knee, you're fumbling in your pockets for your keys, dropping a rogue lemon on the porch, and, well, maybe it's raining. It's clunky.
It is the absolute definition of friction, really. Just a massive physical bottleneck right at the entry point of your home.
Exactly. But imagine just walking up to your door, hands completely full, and the deadbolt simply slides open, perfectly timed to your exact arrival. No keys, no apps, no waiting.
Just completely seamless.
Right. So welcome to this week's episode of Smart Home News. In this episode, we're doing a deep dive into the war on smart home friction. We are looking at a stack of recent developments that span from the famously frustrating, clunky tech of the past to the frictionless front doors of the future.
And most importantly, we're digging into the underlying bedrock, the protocols and infrastructure that makes a smart home actually reliable. Because that infrastructure is really the lens we need to use for this week's report. I mean, flashy gadgets with new sensors always grab the big headlines, sure. But the most critical developments we're seeing right now revolve around open standards and reliable local networking.
We're officially moving beyond the era of the smart home as just like a collection of cool party tricks. It's shifting toward true mission-critical home automation.
Exactly.
To understand where the smart home is going, we really have to look at the holy grail of automation, which is total hands-free access. We're seeing facial recognition smart locks hitting the market in a major way this week.
Yeah, and they're actually proving to be highly effective. The goal is to completely replace the need for physical keys, passcodes, or those really slow geofencing apps that constantly drain your phone's battery in the background.
Oh, geofencing has always been the promise, right? Your phone crosses an invisible GPS boundary around your house, and the door unlocks.
In theory, yes. But in practice, geofencing is notoriously unreliable because of how modern smartphones manage power. To save battery, your phone's operating system will often just suspend background applications.
Right, so the GPS ping gets delayed.
Exactly. The smart home platform doesn't realize you've crossed that invisible boundary, and you still end up standing on your porch for 10 seconds waiting for the lock to wake up. It's not truly frictionless if you still have to wonder if it's actually going to work when you pull into the driveway.
Yeah, that waiting is the worst. So these newer locks are utilizing something completely different to bypass the phone entirely. They're pairing facial recognition with ultra-wideband or UWB radios.
Right, so it's identifying your face, but it's also using UWB to precisely calculate exactly how close you are to the door.
Which allows for a totally seamless unlock right as you reach for the handle. Okay, let's unpack this. Unlocking a phone with my face is one thing, but my physical house. It feels like we are trading physical security for ultimate convenience.
I can see why you'd think that.
My immediate thought is, can someone just hold up a high-resolution photograph of my face to the door while I'm on vacation and walk right in?
Well, what's fascinating here is how the underlying mechanics of ultra-wideband prevent exactly that.
Yeah.
We aren't talking about the old 2D cameras you'd find on laptops a decade ago, which could easily be fooled by a photo.
Okay.
The integration of advanced facial mapping combined with UWB drastically reduces the risk of spoofing because UWB relies on time-of-flight measurements. It measures the exact time it takes for a radio signal to leave the lock, bounce off an object, and return.
Oh, so it knows your exact physical depth and distance in three-dimensional space down to the centimeter.
Exactly.
It's like the lock is throwing a microscopic tennis ball at you in the dark and counting the exact milliseconds it takes to bounce back. Like it's painting a 3D topographic map of your face based on the echoes.
That is a perfect way to visualize it.
So a flat piece of paper or a photograph simply doesn't have the 3D geometry, so the tennis ball bounces back all wrong?
Right. It's looking for a three-dimensional human with a specific radio signature, not just a flat image. But this brings us to a fundamental first principles trade-off that everyone has to consider when building out their smart home infrastructure.
What's that?
Well, true, frictionless technology is undeniably incredible, but you have to weigh the privacy and cloud dependency implications of the hardware you choose. You're now storing biometric data, the actual mathematical map of your face, on a door lock. So the critical question becomes whether that lock processes your face locally on the edge device itself, or if it's pinging a cloud server somewhere to verify your identity.
Because if it relies on the cloud and your internet service provider goes down for an hour, you might literally be locked out of your own house.
Exactly.
There's that delicate balance between incredible convenience and relinquishing a bit of data control.
Yeah.
But, we crave this hands-free nirvana today, but the raw desire to avoid physical friction isn't a new concept at all.
Not even a little bit.
The consumer appetite for this goes back decades. And that was highlighted perfectly this week by a retrospective on a piece of vintage home automation, the clapper.
Oh, man. An absolute classic of early analog automation.
It was a massive commercial hit in the 1980s, primarily driven by one of the greatest advertising jingles of all time. But underneath the marketing, it was notoriously bad technology.
Oh, terrible. The user experience was objectively awful because it relied on incredibly primitive acoustic filtering.
Right. You had to clap, pause for exactly half a beat, and then clap again.
Yep. And if you waited too long, the analog circuitry reset and stopped listening. If you clapped too fast, it just ignored you entirely.
So you'd end up aggressively clapping at your lamp in the dark, which is just the complete opposite of convenience.
And to make matters worse, the relays inside the device were often really poorly manufactured, meaning it could actually fry the gadgets you plugged into it.
Which is wild. This was the ultimate smart home false start. It's the 1980s equivalent of a modern voice assistant that constantly says, I didn't quite catch that, except it might also destroy your favorite appliance.
All right. Yet it sold millions of units.
Exactly.
And if we connect this historical artifact to the bigger picture of where the smart home ecosystem is going today, the clapper's commercial success proved something vital.
Which is?
It proved that the consumer appetite for home automation was already massive. People were perfectly willing to endure terrible, unreliable, and frankly frustrating technology if the mere promise of convenience was strong enough.
They just wanted the magic of a room responding to them without getting up to flip a physical switch.
Yeah.
And that deep-seated desire perfectly sets the stage for the hardware we are seeing roll out this week. Early tech tried to save us the minor effort of flipping a light switch, but modern automation is actually tackling intense, time-consuming physical chores. And it's doing it at price points that are bringing really high-end features within everyone's reach. For instance, we saw a major price drop this week on the Ecovacs Dbot X11, which is a self-cleaning robot vacuum and mop hybrid.
That's a serious machine.
Yeah, it just hit a new low price of $699, which is a massive $400 discount at Amazon and direct from Ecovacs.
The barrier to entry for serious autonomous floor cleaning has traditionally been incredibly high, often pushing past the $1,000 mark for anything reliable.
Right.
So when a premium device drops to $699, it suddenly becomes an option for a much wider segment of users looking to automate their daily chores.
We aren't talking about a basic bump-and-turn robot from 5 years ago that just bounces off your baseboards. This specific model boasts 19,500 pascals of suction power.
Which is incredible.
Just to put 19,500 pascals in perspective, your standard cordless stick vacuum that you push around manually might max out around 3,000 to 4,000 pascals.
Right.
This thing is essentially generating the suction of a heavy-duty shop vac, navigating your floor plan, and washing its own mop pads completely autonomously while you aren't even home.
Exactly.
And speaking of bringing these high-end devices into your home, compatibility is everything. And if you're trying to figure out which devices actually fit your setup, smarthomecompared.com can help you compare smart home products by ecosystem, features, compatibility, and integrations before you buy.
That integration piece is critical, though. As these highly capable devices become more affordable, the conversation needs to immediately shift from hardware specs to software ecosystems.
Right, because you have a powerful machine with cameras and mapping technology navigating your home.
Exactly. Can you pull this vacuum into a local ecosystem like Home Assistant using a local API? Or are you forced to use the manufacturer's proprietary cloud app to schedule your cleanings and store your floor plans?
And if you are locked into a proprietary cloud app, you are entirely at the mercy of that company's external servers.
Yep. If their server goes down for maintenance or there's an AWS outage, your floors stay dirty because your app can't talk to your vacuum.
Even though both devices are sitting in the same room on the exact same Wi-Fi network.
Which is so frustrating. But worse than a temporary outage is the long-term risk. If the company goes out of business or decides to stop supporting that specific model, your highly capable piece of hardware becomes a very expensive paperweight.
Right.
This is why demanding local control APIs is paramount. Your smart home hub should be able to send commands directly to the device over your local network without ever needing the internet.
Which transitions us perfectly into perhaps the most vital development we are tracking in this week's deep dive. Buying a high-tech facial recognition smart lock or an incredibly powerful local robot vacuum is totally pointless if your home's underlying wireless protocol is congested and unreliable.
Oh, absolutely.
We have to look at the invisible infrastructure that keeps the entire system running. The Z-Wave Alliance published a really interesting Two Truths and a Lie piece this week to bust some very persistent industry myths about network protocols.
Yeah.
The biggest lie they tackled is the assumption that Z-Wave is a proprietary, closed-off technology.
This is a misconception that has lingered for years, largely due to outdated information from before 2020. People assume that because Z-Wave has such strict, mandatory device certification, it must be owned and tightly controlled by one single, greedy corporation acting as a gatekeeper.
But the reality is that Z-Wave is an open standard. It's governed by the Independent Z-Wave Alliance, which operates as a standards development organization, or SDO.
Right, they oversee the ecosystem collaboratively with insight from member companies all over the world.
They also highlight how Z-Wave utilizes the sub-gigahertz spectrum to completely avoid the congestion of the 2.4 gigahertz band.
Which is huge.
Yeah, because the 2.4 gigahertz band is essentially a crowded highway where all your Wi-Fi routers, Bluetooth speakers, and even your microwave live. They constantly yell over each other, causing interference and drop signals.
Moving to the sub-gigahertz spectrum is really the secret sauce for reliability. Lower-frequency radio waves penetrate solid objects like walls, floors, and doors much more effectively than higher-frequency Wi-Fi signals.
So your smart light switch operating on sub-gigahertz doesn't have to compete for bandwidth with your smart TV streaming a 4K movie or your laptop downloading a massive file.
Exactly. It has its own dedicated quiet lane to communicate instantly.
And the technical capabilities are expanding rapidly, too. They dropped some incredible stats on Z-Wave Long Range, or ZWLR. A single network can now support up to 4,000 nodes.
Wow.
Yeah. And a node is simply an individual smart device, like a switch, a sensor, a lock. Supporting 4,000 devices with a transmission range of up to 1.5 miles pushes this technology way beyond just a single-family home.
Absolutely. It allows for seamless coverage in multifamily housing, massive commercial buildings, and even agricultural setups where you might need a sensor on a gate a mile down the road.
Okay, here's where it gets really interesting. For years, people assumed this was a walled garden. Why does it actually matter to the everyday user listening to this if the protocol is an open standard governed by an SDO rather than owned by one tech giant?
I mean, it is arguably the single most important factor in protecting your financial investment. Open standards ensure long-term stability and true interoperability.
How so?
Let's look at the mechanics of an SDO. It involves shared patent pools and open source documentation. If one single corporate owner controls a protocol, they can unilaterally change the rules overnight to satisfy their shareholders.
Right, they can suddenly decide to start charging mandatory subscription fees just to use your light switches.
Or they can deprecate older hardware to force you to upgrade, or they can pivot their business model and shut the servers down entirely.
We have seen that happen so many times in this industry. A company gets acquired, the new parent company shuts down the API, and suddenly $1,000 worth of perfectly good window shades just stop working.
Exactly. An SDO prevents that entirely. It gives multiple different manufacturers the confidence to build and invest in products for that ecosystem because no single CEO can pull the rug out from under them.
It directly solves the abandoned product problem that plagues the IoT industry.
Yes. When you buy a certified device, you know it's going to work with your hub today, and it will still communicate with the network 10 years from now, regardless of who manufactured the hardware.
Because it has to pass that rigorous, independent interoperability certification before it can even be sold. It's not just a fancy logo on a cardboard box. It is a mechanical guarantee of communication.
Right.
And that specific reliability isn't meant for flashy gimmicks or syncing party lights. It's engineered for the devices that absolutely must work every single time to protect your property.
Which brings us to a great list.
Yes. This week, the Z-Wave Alliance released a targeted list of 10 essential devices that they argue every professional installer should keep on their truck at all times.
Reviewing this list really offers a masterclass in what a smart home should actually prioritize when you strip away all the marketing hype.
Let me highlight a few standouts from their recommendations. They include the AOTech Water Sensor 8 for early leak detection at sinks and water heaters, which can obviously save thousands in water damage.
Absolutely crucial.
They mentioned the Climax smoke detector for life safety monitoring. There's the EcoLink Z-Wave Plus garage door tilt sensor, which physically verifies if the heavy metal door is actually closed before triggering security automations.
Also very important.
Yeah. And they included the Zoo's motion dimmer, which brilliantly combines a smart dimmer, a motion sensor, and an ambient light sensor into one single device on the wall. But most importantly, they highlighted the FireAvert 120-volt auto appliance shutoff.
The FireAvert is really the quintessential example of mission-critical automation. If we connect this to the bigger picture, it perfectly illustrates the necessity of robust, purpose-built IoT protocols over cloud-dependent Wi-Fi gadgets.
For those unfamiliar with the hardware, the FireAvert integrates directly with your existing smoke alarms. If it detects the specific acoustic frequency of the alarm going off, it immediately cuts physical power to your electric stove at the outlet to stop a kitchen fire from spreading.
It's brilliant.
It is. This list is essentially the emergency medical kit for your smart home. It's not about RGB party lights syncing to a Spotify playlist. It's about making sure your basement doesn't flood while you're at the office, or that your kitchen doesn't catch fire while you're asleep.
Right, because if we break down the exact sequence of events during an emergency, it all comes back to the absolute necessity of local control and network reliability.
Give us an example.
Imagine you are cooking. A grease fire starts on the stove, and the smoke alarm triggers. Simultaneously, a storm outside knocks out your internet service provider. Or maybe your Wi-Fi router simply reboots.
Oh, wow.
If your smart home relies on cloud-dependent gadgets, that smoke alarm cannot send a signal up to a server in California to tell the server to send a signal back down to your stove to shut off. The chain is entirely broken by the Wi-Fi outage.
So the house burns down because the router was updating its firmware. That is a terrifying structural flaw.
It is entirely unacceptable for life safety. But because devices like the FireAvert use a robust protocol like Z-Wave, operating entirely locally on that sub-gigahertz mesh network we discussed, the architecture is totally different.
Right.
The smoke alarm communicates directly with your local hub inside your house, which instantly sends a sub-gigahertz signal to the FireAvert plug to cut power to the stove. No internet connection is required at any point in the process.
When we talk about protecting property and human life, the technology simply cannot rely on the cloud. It has to work every single time, just like flipping a physical copper switch used to work, but with the added intelligence of a system constantly looking out for you in the background.
Precisely.
So, what does this all mean for the everyday user? If we look at the whole picture of this week's news, we are clearly moving away from the unreliable mechanical friction of the past.
We really are.
We've come a very long way from violently clapping at our lamps, hoping an analog relay catches the sound, to having our front doors seamlessly unlock by calculating the time of flight of radio waves mapping our faces as we walk up with our groceries.
It's incredible progress.
It is. We are also seeing incredible industrial-grade hardware like 19,500 Pascal robot vacuums, dropping to price points that bring them within everyone's reach to automate heavy physical chores.
Yeah.
But the real heroes making all of this automation possible, and more importantly, making it bulletproof, are the open standards and the dedicated sub-gigahertz protocols like Z-Wave.
Absolutely.
They are the invisible bedrock that keeps our homes secure, ensures our critical automations run locally without the internet, and guarantees that the thousands of dollars we invest in these devices today won't be abandoned by a corporate server shutdown tomorrow.
We are witnessing the crucial evolution from collecting disjointed smart home gadgets to building true, resilient smart home infrastructure.
It is a serious craft worth learning if you want a home that actually works for you rather than against you. And if you found this weekly report useful in helping you navigate that infrastructure, please take a moment to rate the podcast and leave a comment on Spotify or Apple Podcasts. It really helps us continue to analyze these ecosystem changes every single week.
As you think about where all this frictionless technology is heading, I want to leave you with a final thought to mull over.
That's that.
We talk about how secure 3D facial recognition and ultra-wideband radar are becoming the absolute standard for our front doors. How long until our homes apply that exact same localized tracking technology internally? Imagine an indoor UWB mesh network that tracks your physical radio signature as you move through the house.
Oh, wow.
How long until your living room recognizes exactly who just walked in and instantly tailors the lighting temperature, the ambient audio, and the blind positions strictly to that specific individual's historical preferences, all without a single voice command, an app, or a clapped hand.
That is wild to think about. The frictionless front door is just the entry point. The entirely frictionless living space is what comes next.